All right, so today we're going to practice graphing more. We're going to really dig into transformations. And then this is what I'm expecting you to be able to do. So if you look on your practice test on number, let's see. So your practice test, like number 16 and 17, the transformations of these functions, this is what we're working on right now, is the transformations. And then how do you actually graph these? Like, that's the second part. Once you know how it's moved and transformed, you can easily graph absolute value. Okay, so we are on this one right here. Use your calculator to graph the parent function, absolute value of x, or I'm sorry, square root of x, and y equals square root of x plus 3. So I go to my calculator, and I want to push on graph. So hopefully we are all right here. We have our calculator out. We're going to practice. I have graph. And what happens? Like, look, if I don't have my entry line, you just push tab, and it will pop up for you. Okay, so remember, tab is right here. This says TAD tab, and then this will pop up, and that way I have a place to write my function. All right, so so if you had like some stuff in there, like, so you've got something like this in there. Okay, so if I can push tab, scroll up, and then you just push the DEL button. So that's highlighted right there. Delete, and then I want to delete until I reach the equal sign, and then I want to leave it alone. What you can do, you can push like enter, and then, oh, it actually disappears because I deleted my function. All right, so I'm here. So the first one I need to graph is square root of x. So remember, you have to push control and then the x squared key to reach the square root that is in blue above it. Okay. And then I just type in x inside. And then you can push the down arrow key to reach the next line to insert the second function. So I'm trying to go nice and slow so we see where the buttons are.
Press the tab again.
So if you push the down arrow, it will go to f2 of x. Okay. So do you have the command line? No, so you have to push tab again. That way it pops up because you don't, yeah, there you have it. All right, the second one we have to insert is square root of x plus 3, and the plus 3 is inside? No. Is it not? I forget. Yeah? Run. This one, okay, cool. So x plus 3. So I had to push control, x squared, x plus 3, push enter. Wow. X plus 3. Okay, so we notice it moves to the left. Is this what it looks like for you? Okay, and so notice, oh, let me move this a little bit so it's easier for us to see, especially since I'm screencasting, just so I can point it out. Notice I have this plus 3 right here, but our graph moves to the left. But there's a plus 3, so if you would think like, oh, plus 3, I'm going in the positive direction, but you're not. You're actually going the opposite way of what you think. Right, so you'd be going 3 to the left. So if you haven't already, draw it on your notes. It doesn't have to be, exact, perfect. You just want it to look like, the little movie theater move. Did we talk about this already? A little bit? All right, you're in a movie theater. You know that, it's like cliche. They're like, roar, like yawn, and then they put their arm around. That's literally what the graph looks like. It's a little, curved like your arm. No? Okay, whatever. The point I care about, you are starting at 0 with... so starting right here at 0 when you have absolute value, or when you have square root of x, and then the plus 3, you're starting at -3, and then just curving up. So I don't care about every single point. I want you to get the gist, right? I want you to see, oh, it's literally like my purple one, my original graph is moved by 3 to the left. That's it. And then how did it move? It moved to left by 3. Awesome. So let's go ahead and let's try the next one. 2 to the x. And 2 to the x plus 5 power. So I'm back on my calculator. My command line is gone, so I have to push tab. Oh my gosh, it says f3 of x, but I need to get to my first 2 functions, so I have to scroll up. And then I delete till I reach the equal sign. Scroll up until I reach f1 of x. Delete till I reach the equal sign. And then I can put 2 to the power of x. So notice you have to push the little caret key. It looks like an up arrow almost. It's highlighted in red so you can see where it is on your calculator. And then you put x in the exponent. That's a weird looking graph. It's actually a power function. You haven't learned about it yet? Probably ever. But we'll learn about it later. So without graphing the other one, what do you think is going to happen to it? Left by 5. See, amazing, amazing. You guys knew exactly what was going to happen without even knowing like what the heck this function's doing. Oh, my command line's gone. I have to push tab again. Now I can insert 2 to the x plus 5 power. Sure enough, it did. It moved to left by 5. So if you are adding or subtracting a number inside the absolute value, inside the parentheses, if you're squaring or cubing, inside the exponent, right? If it's some number to an exponent, like inside, whenever you're right next to x, that's going to be horizontal. Versus, what would happen if instead of I did 2 to the x plus 5 power, what if I did 2 to the x and then do a plus 5? What would that do? Do you understand what I'm trying to ask you? So what would the difference there be? So let me just write it so we're all clear. All right, so this is what the graph looks like. But my question to you is, how does 2 to the x plus 5 compare to 2 to the x and then plus 5? What is the difference between these two? Do we know? So this 5 is not in the exponent. So what does this do? Do we know? Moves it up 5. Versus, oh look, it's in the exponent with x. It moves it to the left. So we're talking about a horizontal move versus a vertical move. Okay, so that's the next thing that we're going to be talking about. Okay, so how did it shift? We know it shifted left by 5. Analysis questions. Well, what type of movement? Left and right. Literally taking the graph and shifting it. We're not like stretching it. All we're doing right now is taking it, move it over, shift it over. Okay. It's kind of like you're pushing a box or something. You're just moving it. You're not changing the size. You're just shifting it side to side. And then what is weird about how these graphs move? It's literally the opposite way of what you think, right? I see a plus 5. Oh, it's actually going in the negative direction. Exactly. If it was a negative 5, it'd mean it's moving in the positive. So that's what I mean when I say moves in the opposite way you think. You would see a plus, you think going to the right, going to the left, but that's only for horizontal, only for horizontal. All right. And then let's describe how each pair of graphs would move differently. So try not to show you the answer. So y equals x squared plus 1 versus y equals x plus 1 squared. So notice this right side. Oops, sorry. Let me just erase this really quickly so we can not see the answer. Okay. How is this different? So we already kind of talked about this. Being outside or inside the parentheses, inside the square root, versus on the outside. So how does this first one move? Let's, Eli, do you want to help me out with C?
So it goes, I think, up by 1.
Yeah, up by 1. Literally, I take the x squared graph, shift it up 1. Versus, what about the second part of C, Ashton? What's going on here?
Oh, the second part is C, since it's inside, isn't it horizontal?
Yep, which way is it going?
Going the opposite way, which is negative 1.
Which is left by 1. Yep, left 1. So shifting the whole graph left by 1. All right, Jesse, do you want to try out the first part of D?
Yeah.
So when I say describe how it's moving, I'm looking at like compared to just absolute value of x. How is this one moved? Huh? Well, it's outside the absolute value. So down by 7. So if it's outside the absolute value, outside the parentheses, it's up and down. Versus inside, you see how I have absolute value of x minus 7 right here? Since it's inside the absolute value, it's going to be going horizontal. But I see a negative, which means it's going to be going to the right by 7. It'd be going in the positive direction. So what I'm really wanting you to see is like, if I have if I have something on the outside versus inside the parentheses, the number being subtracted outside the absolute value versus being inside the absolute value. So if it's inside the parentheses, inside absolute value, it's a horizontal. If it's outside and you're adding or subtracting, it's going to be vertical. Okay. let me erase this really quickly. Let's go through these. Oops. Did not mean to do that. Okay. So let's continue. Talia, what about 1? How is this moving? How is this shifting?
To the right.
Yep, the right by 1. And also, what is the plus 6 doing? Okay. Just gonna have Talia finish it. It's all cool though. Up by 6. As long as we're grooving with it. Let's just continue down the row. Dylan Benson. What about B? Awesome. So we see inside the parenthesis, inside absolute value sign. That's where I'll have my horizontal. Then I have 5. Question is it going left or right? Horizontal is always opposite what you think. So since it's a plus 5, I'll be going in the negative direction. So that's left. Left by 5. And then he said up by 10. Because notice it's like away from the cube. It's not inside the cube. It's just tacked on the end. That's my vertical shift. All right, Miranda, what about C? What do you think about C?
I think it's inside the parentheses, so it'd be right by 3.
Beautiful.
Opposite, and then it'd be down by 1.
Exactly. Exactly. Okay, so I'm going to give you about 5 seconds or so. I want you to try number 2, and then you'll share with the person next to you, and then we'll do it together. So write an equation for an absolute value function that's shifted up by 3. So see if you can do it yourself. Right, we're shifting it up by 3. So what would this look like?
Do we have to write like a new equation?
Yeah, so it's going to be y equals, and then it should be an absolute value shifted up by 3. So turn to the person next to you. Let's see if how you guys compare. Maybe help each other out. Compare with each other. Maybe, Elizabeth, do you want to compare with Dylan? Okay. All right, so what do we think? Who wants to volunteer? I think Talia.
I wrote y equals absolute value x plus 2 plus 2.
Let's see. So
Absolute value x plus 2.
plus 2. Oh, it shifted up by 3 though, so it should be plus 3. But yeah, so notice
No, I
that.
know, but I wrote x plus 2 inside.
Oh, so we're not shifting it horizontal, so it should just be absolute value of x plus 3. Should just be absolute value of x and then plus 3. Notice the 3 is outside the absolute value, so that's a vertical shift. So the next one is a shift left, so it should be a horizontal. So try to write it. Give about 5 seconds. Think about how you write a horizontal shift. Compare it to the person next to you if you've already finished. That felt really good. Did you guys compare already?
Yeah.
All right. All right. Yep. You do it? Sure. Okay. So what's it going to be?
Y equals x plus 6.
Absolute value of x plus 6 is on the inside.
Does it have to be? Oh, absolute.
Because it says absolute value, so you have to have the absolute value symbols. And shifted left 6, exactly. So left 6, you would think it's minus 6, but it's tricky because it's horizontal, so it's always opposite what you think. So it's going to be a plus 6 on the inside. And now, for the grand finale, let's do one with both. A shift down by 3 and a shift right by 6. So all of these are like fair game because it's all about absolute value. That's really the only special function we're working with in 2.6. We've I had you graph other functions just so you had a little taste of it, so you maybe saw it before and you get the general rule, but really absolute value is what I'm going to be asking you. Okay, shift down by 3 and right by 6. Ruby, do you know?
I think so.
Okay.
Y equals absolute value of x minus 6. And then outside plus 3. Minus 3.
So it's minus since it's down.
Okay.
Exactly. So vertical is just whatever it is. If it's down by 3, it's -3. Up by 10, it's a +10. But the horizontal where it's tricky, so if I'm going to the right by 6, that would be a -6 inside. Perfect. All right. So now, yeah, we can totally finish the rest. Group 3 is reflections. So let's use the calculator to graph absolute value of x and negative absolute value of x on the same graph. So we go back to our graph. Oh my gosh, I gotta push tab so I can delete all my stuff. And let's think about how we get the absolute value symbol. Have to push the math template key. It is to the right of the number 9 button. The math template key, scroll over to where you see the absolute value and then click on it. And I have absolute value of x. And you can push the down arrow to go to your second function. So this is where we're at right now. To push the template key again, reach over where we have absolute value. I put an x inside, but this time I had to scroll to the left between the equal sign and the absolute value and put a negative. Because remember, we're trying to graph absolute value of x and negative absolute value of x. Weird. So what it did, well, how do we describe what happened to it?
It's just the same on
Same, but
Reflection.
it is a reflection. It's mirrored across. It's literally flipped across the x-axis. So I come over here, I draw it, and like, how did it change? Oh, it flipped across the x-axis. You could say it's a mirror image. It is literally just flopped over, flipped across, reflected across. So we see putting a negative sign in front of a function causes it to switch. So what does x squared look like? Do you remember what x squared looks like? It's like a U shape. What happens if I had negative x squared? Let's try it. Ready? Let's all do it together. Okay, ready? Absolute value of x. Hey, it's a v. Yeah. Absolute value of x. Looks like a v. All right, straight v. Come on, Ashton. Straight v. What about negative absolute value of x? Down. Okay, what about x squared? Looks like a U shape. Negative x squared. Down. Okay. What about x cubed? Looks like this. What about negative x cubed? Literally flips it. Whatever was negative. Okay, so it's like this. Whatever was positive flips to negative. Whatever is negative flips to positive. It's a dance class. You should get PE credit. Whatever. You know what? But you just won't forget it. It works with my pre-cal kids and my calculus kids. That way they like know the basic functions, because if you like think about it, you say it, you write it, and you do it with your arms, we'll get into your brain. Okay, so what's happening with this in group 3? It's a reflection. And we already did this. Guess what? It's literally mirrored. So if we're looking at x cubed versus negative x cubed, it's just flipped. It's mirrored. And to prove it to you, we're going to do it on our calculators. Okay. So we did it with our arms. We did it with our arms already. We're going to do it with our calculators. So I go up. I'm going to change this to be x cubed. Mirrored. Flipped / it's mirrored. So if I'm looking at x cubed, it's the blue one. Notice it just, whatever was negative is now positive, and whatever is positive now negative. It just literally mirrors it. It flips it across. So this is showing you the last problem that we did, proving that it's flipped and mirrored. And now we can go through stretches and compressions. All right, so what we've been doing is we haven't been like changing our graph in the sense of like stretching it. What we've done is we've moved it up and down, side to side, we flip it, but now we haven't like stretched it yet. So that's the next step. Stretches and compressions. So we're going to use our calculator to graph the parent function y equals absolute value of x and y equals 3 times absolute value of x on the same graph. Let's try that out. Lots of practice graphing, lots of practice.
We're gonna use the calculator on the test. We're not just gonna be graphing these things.
I mean, I'm gonna let you use a calculator, but there will be like, for if it's this test or not.
For like just those parts.
Why not when we review, we'll like talk about it when we review for our test.
Okay.
Yeah. So I have 3 times absolute value of x, and then I need to do, so you change this one to be absolute value of x. Yes.
I don't know what I did.
You don't know what to do?
No, I got like a totally different.
So this is what it should look like.
No, like,
Alright, let's see. So, push escape. Okay, so now to push tab. And then, see how it says relation? So you have to go menu, graph entry, edit, click on function, which is number 1. Cool. And now you can insert it. Alright, this is what your graph should look like. If you haven't already, go ahead and put it in. So notice what's happening if I have a 3 in front being multiplied by my absolute value.
Skinny.
Gets skinnier. So we talked about this the first time we graphed absolute value. So I'm taking absolute value, which has a slope of 1. And this one I do want you to be more precise. Because what is the slope going to be?
sorry, I left it here from last.
Phone? Yeah, just grab it. Just show. What should the slope be of the second function?
It should be skinnier.
What's the slope?
3 times skinnier.
3. So literally, remember how the slope of absolute value was 1? Here, the slope going to the right is positive 3. Slope coming from the left is negative.
Where do you start the T?
No. Because if you put in x equals 0, you get 3 times 0. Because here's the values for absolute value of x. Here's my x and y values. Like -2, -1, 0, 1, 2. And my y values are 2, 1, 0, 1, 2. But if I do 3 times absolute value of x, what I'm going to be doing here is multiplying all of my y values by 3.
So why would you start at 0 again? Like, how can we close 3?
So I'm multiplying all my values of 0. What's 0 times 3?
0.
0. So this gives me my y values. So literally what this 3 in front of it does, it takes my old y values and multiplies them by 3. I'm stretching it by a factor of 3. So at this point right here, it used to be a y value of 1. Multiply by 3, I get 3. Here, this has a y value of 2. Multiply by 3, I get 6. So this 3 in front is multiplying the parent function by 3. It's stretching it by a factor of 3, yes. Sure. All right. So how did the graph change? We already talked about this. Skinnier, sharper. Is that how you spell skinnier? I think it is.
I don't know, I can forget.
So use your calculator to graph the parent function y equals x squared and y equals 4 times x squared on the same graph below. Okay, so x squared and 4 times x squared. So go back to my calculator. Have to scroll up to delete the functions. So we have x squared. And we want 4 times x squared, right? So 4 times x squared. Interesting. What's happening here? It got skinnier. Okay, cool. This one, the points aren't nearly as important, but notice we're starting them both at 0, 0. So that's 4x squared. It got much skinnier, right? So it's almost like we are stretching it taller. It's got skinnier. It's almost like we took our old function and compressed it horizontally. What do I mean when I say compressed horizontally?
Squeezing it.
Squeezing it together. It's like if you're having an accordion or maybe like some bread or a sponge or something really soft like a pillow, and you squeeze it horizontally, right? You're making it smaller. You're coming from both sides, making it smaller. So you could say compressed horizontally, or you could say it's stretched, a vertical dilation. So if you ever go to the eye doctor, they dilate your eyes, your pupils get bigger. So a dilation means you're getting it bigger, you're stretching it vertically. All right, so what type of movement is this? Stretching and compressing. Stretch and compress. So let's describe how each of these change from the first to the second. So what is happening here in F? Who haven't I asked yet? Let's go to Lauren. What's happening with this F?
The F? Well, there's
Hmm?
There's one. Oh, that's
The F.
Oh, the 6. There's a 6 in front of the square root.
Yep, so what does this do? What does this do to it? So compared to root x, what does the 6 in front of it do? It's going to stretch it, right? It's gonna stretch it vertically. All right, this is a tricky one. Who's up for a challenge? Eli? All right. What about G? So notice we've been working with numbers larger than 1 in front, but a half, what will a half do?
Well, that's the same thing as dividing it by 2. So would it, I guess, compress vertically?
Yep. So what you can say for the first one is stretch vertically by a factor of 6. And the second one, compress vertically by a factor of 2. So by a factor means by how much. If you're compressing, you're making it smaller. How much smaller? Literally halving it. First one, stretching it. How much bigger? Factor 6. You're multiplying by 6. All right, in conclusion, putting it all together, describe how the function would shift up, down, left, right, reflect, and stretch or compress. So putting it all together. Y equals negative absolute value of x plus 6. What do you think,
It
Ashton?
would be the weird thing because it's negative, so it'd go like down.
So the negative here, it reflects it,
Yep, reflection.
reflects, and
And the 6, since that's on the outside, it would go up and down. Which
moves it up by
means
6.
That goes up by 6.
Exactly. So it will flip it and then shift up by 6. So it's like you have absolute value and it flips it and then you shift it up by 6. So you have this, then you flip it down and then it shifts up. Okay. So write an absolute value function for the graph below. This is pretty funky, right? Because this doesn't look like a normal absolute value. Am I translated? Did I move horizontally at all?
No.
No, right? Because normally absolute value starts at 0, 0. Did I move vertically at all?
No.
No. Okay. So did we flip? Is there a reflection?
No.
No. So the only thing is a stretch or a compress. So, right, that's the only thing that's going to happen. Normally, what is our slope when I go to the right? Normally, our slope is 1. What's the slope here? 1/3, right? Rise of 1, run of 3. So we have no horizontal or vertical shift. So I'm writing this, like you don't have to, but I'm trying to make it clear so when you look at the notes later, no horizontal or vertical shift. Because originally our absolute value starts at 0, 0, and here we're starting at the origin as well. Okay, and there's no reflection because it's pointing up like a normal V. But I see normally absolute value, right, has a slope of 1, go over 1, up 1, over 1, up 1. Here, over 3, up 1, so slope is 1/3. So this would literally just be y equals 1/3 absolute value of x. Beautiful. So for you guys, because I like cut a couple pages of the notes for my other class, just like, because you guys are like, we're always a day ahead of them. So for you, these 2 pages are true, but for my A period, the 2 pages are probably like 41 and 42 or something. So, but for you, like this is part of your homework. Literally, you just graph these 2 functions. Okay, it deals with compression and stretching, and then it's these 2 pages of notes, 43 and 44. So these 2 pages of notes are homework. So these 2 I'm showing right now. It's literally 8 problems. No, because we're going through 2.8. Today is 2.8 today. But what we are going to do is, wait, so 43 and 44. I'm going to do these first 3. We're doing these first 3 together as an example.
Is there 2.8 number?
What?
Is there 2.8?
No, this is 2.6. We're going through 2.8 today as well.
Yeah, and then we have 2.8 homework as well.
Yeah. Yeah. Because most of this, I mean, like you could do like this example 1, like you can do absolute value. Just to review, translations move up or down, left or right. Reflections flip over a line of reflection, and dilations shrink or enlarge. So this is what I was talking about with compressing or dilating, right? It stretches by a factor. Talia, sit up. So if I want to recall the absolute value function, so it's just a slope of 1. So you have to draw a line where it's like over 1, up 1, over 1, up 1, over 1, up 1, over 1, up 1, to going to both sides. So where is the vertex? Yes. Sure. Where is the vertex?
Zero.
Exactly, 0, 0. It's the bottom of the V, so 0, 0. So these next ones, you just have to graph and then state where the vertex is. All right, so example 2, graph the following transformation, state the vertices. So that's like why I gave you the next 2 pages is like part of your homework. So, I mean, it goes pretty fast. Like this one, okay, so what's the transformation for A?
That would be
Up by 3. So normally we start at 0, 0, I go up to 3, and then I go up 1, over 1, up 1, over 1, up 1, over 1 to draw my V. So if you know the transformation, it makes it much easier. All I did was I drew the absolute value function, but I shifted up by 3. Let's chill. Okay, so the new vertex is 0, 3. So as long as you know how to do absolute value of x, you'll know how to do all the rest. Because the transformation is like, okay, cool. So normally we go over 1, up 1, over 1, up 1, over 1, up 1 to both sides. That way it's a nice little V. Transformations say, hey, just move up 3. And now you start there and do your over 1, up 1s. What about this next one? What is the transformation, Elizabeth?
Just move down 4.
Yeah, move down by 4, so I go down to 4. And then I over 1, up 1, over 1, up 1. Just draw my slope of 3 till I reach the end of the graph. I'm sorry, slope of 1 till I reach the end of the graph. You're just going from like tick mark to tick mark. That way it's over 1, up 1. And my new vertice is going to be 0, negative 4. Perfect.
I did this wrong already.
What? Which one?
I already did this for homework, but
Already did.
I did the vertex.
Ah, so you just redo the vertex? Yeah. Okay, and so we can figure out the vertex. I think that would help you. We can figure out the vertex for C and D. What will the vertex of this one be? Of C, before we even plot it. What's happening here? Exactly, it's going to be 6, 0. Because it's shifting over by 6. So make a dot here. Might as well just do it, whatever. And then what about the vertex for D? That way you only have 6 problems to do. What about the vertex here? So what's the transformation? Huh?
Is it -2, -3?
Exactly, -2, -4. Because it's our new vertex just says how much did we move horizontally? Left by 2. How much did we move vertically? Down by 4. So I go to -2, -4. And then I just draw my absolute value function starting from there. With a slope of 1 going all the way to the end of the graph. Woohoo! Okay. Perfect. Awesome. That way you just have like 6 problems. Shouldn't be too bad. Oh, did I literally give you those same problems? Oops. Yeah, I realized that these 2 are actually below. My bad. Might as well do them again. Alright, so that's 6 problems for you to do. We're going to go through 2.8. It's not too bad. You guys already pretty much know it. When I say pretty much know it, 100%, this is an Algebra 1. It's just a review of Algebra 1. 2.8, graphing linear and absolute value inequalities. So, when we say boundary, it's a line or curve that separates coordinates in the plane into regions. So here our boundaries are going to be our lines, and then we're going to be shading one side. So the half plane is the region of the graph of inequality on one side of the boundary. All right, whatever. Who cares what that means? But how do you actually graph them? How do you graph inequalities? So these are not equal signs. They're like greater than, less than, greater than equal to, less than equal to. So you choose a dotted or a dashed line if you just have the greater than or less than. But if you have an or equal to, you just draw the solid line like you normally would for an equal to. Then you choose a point from each half plane to test it, and you shade where it makes it true. So it's a lot of words. Doing it makes more sense. So if I have x is greater than 2, is this going to be a solid or a dashed line? Dashed. It's dashed. Okay. Where is the line of x equals 2? Is it a vertical or horizontal? Vertical. X equals 2. So this would be the line of x equals 2, but notice I have a dash because it's a greater than or less than symbol. It's a greater than or less than, right? It doesn't have an or equal to, so I had to do a dash line. And then I have to pick a point and see if it's true. That way it tells me if I shade that side or not. So I'm going to pick 0, 0. Notice this is not on my dash line. I can pick it. So I insert this in. What is my x value of 0, 0? 0. Okay, is 0 greater than 2? No. Since that's false, guess what? That half of the graph where it is located will not be shaded. I get to shade the other half. I shade this half. And just to prove that this is true, let me pick another point over here. Let me pick like 6, 0, right? So what's the x value of 6, 0? 6. Is 6 greater than 2? Yeah, since it works, that half has to be shaded. Do you remember this a little bit? Maybe? Yeah. Okay, cool. Let's try another one. Y is less than or equal to -1. Okay, so y is constant. It's always going to be -1. Is this going to be a solid or a dashed line? Solid. Why? Because there's the or equal to. Exactly. So I have a solid line because it's an or equal to. And now I just have to pick one point. I really like picking the origin, 0, 0. But you only can pick it if it's not on the line that you're drawing. Notice it's not on the line. So I'm going to go ahead. I will pick it. And I'll see if this is true. So for my point, 0, 0, maybe I should label it over here. So the y value 0. Is 0 less than or equal to -1? Is 0 less than -1? 0 less than it? No, that's not true. It's greater than. So I know that half, since that's not a true inequality, I can't shade the side where it's on. I have to shade the other side. And just to make sure we're doing it properly, we can pick another point that's on the side that we shaded to double check we did it correct. So I'll pick maybe, how about this point right here? 0, -5. The y value is -5, so I'll test it. Is -5 less than -1? Less than or equal to? It is. So since it works, that is the side that should be shaded. Perfectos. Okay, so literally this lesson is graph the line. Pick a point. Is it true? Shade that side if true. Is it not true? Shade other side. Okay, and we're just going to practice for the next 15 minutes. You can do it. Let's try the next one. Do I need to pause so you can draw this a little better? Okay. So you just shade, nice light. Let's chill. Okay, y is less than x plus 3. Okay, what would the graph look like if I was plotting y equals x plus 3? What's the slope? Where's my y-intercept? Y-intercept is?
Slope is 3.
Y-intercept is 3 and the slope is 1. So I drop a dot at 3 and I know my slope is 1, but is this going to be a solid or a dotted? Dotted. So I'm just going to do it. I'm just going to do dash lines. It's easier for me. Slope is 1, so it means over 1 up 1. Oh my god. Over 1 up 1, over 1 up 1. Okay. So you're just graphing the line, except if it's not an or equal to, you have to do dashed. Oh my god. This is... Okay. I think that's dashed enough. You can see it. So I drew it dashed because it's just a less than. So it tells me dashed, dotted, whichever one you want. It just can't be solid. Now I have to decide. Pick a point. I like picking 0, 0 because it makes it really easy to plug in and solve. But you have to make sure your line does not go through the point you choose. Okay, so I'm picking this point. This is 0.00. And I'm just going to plug into the equation. So I have 0 less than 0 plus 3. So I'm asking, is 0 less than 3? Is 0 less than 3?
Yeah.
Yeah, okay, that works. So whichever side that my point was on, guess what? I'm going to shade it. So I come up, let me just grab a color, and I'm going to shade the half that has that point inside of it. Perfect. Okay. Just going to continue on. Let's try the next one. Ooh, tricky trick. This is in standard form. You know what makes it easy? Putting it in slope-intercept. How would I move this to be in slope-intercept form? Subtract x on both sides, so I have y is greater than negative x minus 2. This is in slope-intercept form. Your y-intercept is negative 2. Slope of negative 1. Interesting. So wait, is this going to be dotted or solid? Dotted. So maybe if I just, put dots where the slope is, that would make it work. Dotted or dashed, as long as it's not solid, it tells me you know what you're doing. And then I need to pick a point. You can pick any point. I can pick literally any point as long as it's not on the line I drew. Which point would you like to choose, Dylan Bookbinder? Which one? Which one? Just choose one. It just can't be on the line that we drew. Literally any point on the graph, but as long as it's not on the line we drew. Negative 5 and what?
0.
Right here? Perfect. All right, let's pick it. Negative 5 and 0. So I plug negative 5 in for x, 0 for y, and it should be greater than negative 2. All right. So is negative 5 greater than negative 2?
No.
No, it's not. Negative 5 is less than. So since that's not true, that means the side it's on is not going to be shaded. I have to shade the other side. Beautiful. Beautiful, beautiful. So it just shows you, doesn't matter what point you choose as long as it's not on the line. Pick any point, just can't be what's on the line. Plug it in, see if the inequality is true. If it's not true, you shade the opposite side. If it's true, you shade that side. Perfect.
Basically like dropping a number line, but the shading is the arrow direction.
Okay. So let's see, do I want to... This is the exact same thing. This is if we graph absolute value inequalities. Yeah. Okay. Let's do these two and then we can do an absolute value one. Okay, so how do I get this in slope intercept form for E? Add x on both sides. So I have 2y is less than or equal to x plus 4. Now what? I need it in slope intercept form. Talia, sit up. Yeah, let's divide by 2 everywhere. So I have y is less than or equal to 1/2 x plus 2. So solid or dotted line? Solid. Okay, so if I just graph the line y equals 1/2 x plus 2, that's literally my boundary. My y-intercept is 2, draw a dot at 2. My slope is 1/2, so rise of 1, run of 2. And it's going to be a solid line. Solid line, just put a couple dots for me and make it easier. Solid, solid, solid line. Okay, because it's an or equal to, it has to be a solid line. Next step. Miranda, what's the next step? What do we do? Pick a point. Which point do you want to use? 3 what? 3, 0. Okay, cool. So right here? Yeah, valid. It's not on my line. I can use it. Let's plug it in. Let's do this. 3, 0. So I'm plugging in 0 for my y, 3 for my x. So I have, let's see, 0 minus 3 is less than 4. Is negative 3 less than or equal to 4? Yeah, okay, cool. So guess what? That works. So that is going to be the half that we shade. How are you guys feeling about this so far?
Good.
Is it... Shall we do some more examples of, you want to do more examples? You're going to do the inequality or absolute value one? Okay, cool. Let's do F. Let's do F. 5x minus 1 is greater than y. It's in slope-intercept form already. Blessed. Solid or dash line? Dash, because it's just a regular. Okay, because there's no equal to. All right, where is my y-intercept? -1. What is my slope? 5, yep. So rise of 5, 1, 2, 3, 4, 5 over 1. Rise of 5, 1, 2, 3, 4, 5 over 1. Let's see, down. So I have to continue. So I'm going to just like maybe draw some dashes in between because these are pretty sparse. Just to make sure. Okay. So I graphed the line. I had to make sure it was dashed because it's a greater than. If it was an equal to, we would have a solid. Otherwise, we just have to leave it this way. Now I have to decide which half to shade. Ooh, so I need to pick a point. Jesse, what's a point I should choose here? You just want to pick one for us? -4, 0. Awesome. Perfect. You could like literally pick any point as long as it's not on the line. Go ahead, let's plug this in. All right, so I have 5 times -4 minus 1 has to be greater than 0. So I have -21. Is that greater than 0? -21 greater than 0? No, it's not, which means we shade which side? Well, you picked a point on the left side.
Oh,
You have 50-50 shot. Ah! All right, so the point we plugged in, it didn't work. So that means that side cannot be shaded. So it's shade the side where it's not on. All right. Perfect. Okay, so we shade that side. Okay, cool. More. Let's do the absolute value one. So this is just more examples. All right, so what we do is we're gonna graph it just like it's a regular absolute value. Is this gonna be solid or dashed? Solid, because it's not equal to. All right, so how is my graph, how is it transformed? Right 1 and up 3. Okay, so I go over 1, up 3. Is this going to be facing up or down? Is it reflected? No, there's no negative sign in front of it. But what I do have is a 2. So what is this 2 in front going to do? Make it like so it's skinnier, right? Okay, so by doing this part, by moving it right there, I took account those -1 and the 3. It's gone now. I moved my vertex. So if I didn't have that 2 in front, I could just do over 1, up 1, over 1, up 1, over 1, up 1. But I have a 2, which means it's over 1 and up 2, over 1, up 2. So this 2 in front tells us more or less the slope once I moved my point over. So I have a slope of 2.
So that 2 is just the slope.
Yep, the number in front will just be the slope. If it was negative, it just would be flipped, and then the slope would still be like over 1, up 2. All right, so I had a solid line because it was an or equal to, and then I just have to pick one point and decide which half to shade. You just have to make sure it's not on the line you choose. So I'm gonna pick 0, 0. I don't know why they are let out a little early. Pick 0, 0. I'll go ahead and plug this in.
I don't understand what you do with the 2.
With the what?
With the 2.
So the 2 right here was the slope. So I went. So it's telling me how much I stretched it by. So instead of going over 1 and up 1 like a normal absolute value, I went over 1 and up 2 because now the slope for going to the right is 2.
So how do we know the difference between the 2 and the 3?
The 2 is being multiplied to the absolute value. The 3 is being added. So whenever the number is in front of absolute value and it's being multiplied, that tells you the slope. All right. So 0 is 0 less than or equal to 5. Yeah, that's true. So the half with that will be shaded. So I'll shade this whole part.
The whole outside?
Yep. Perfect. Alright, awesome. So, of course, like, this is more examples, but really, 9, 11, 13, 15, 17, 19, 40. So there's 7 problems for this assignment, and I think I just left you, like, 6 to do for the other one. So that's not too bad. So I'll see you guys on Wednesday. We'll review, go over the practice test, we'll go over more examples, maybe do some homework, and then your test is Thursday. And I'll email you if you have extended time to come Thursday lunch. Perfect. Have a good weekend.